Alright everybody, I'm back with another video. I finally got my second motor in. This is a 24 volt DC motor. You can see right there on us. Let me turn the camera and you can see it a little better. See, 24 volt, it's a DC motor. I'm not even using this one yet really because it takes so much voltage. I mean, it's good, it's a real good motor. Like, I like it because it's more sufficient. Like the torque and everything's a whole lot better. And I got the other generator pump thing in. I got both of them. They're secure on here. I went ahead and I'm gonna do something in the future. That's why I have this set up like this. So basically my new pump is on the top and my new motor and, well, basically the new generator is on the top and my old one is on the bottom, as you can see right there. Still got the magnets, neodymium, 4 on each side. And I still got my generator over there, as you can see, connected to that motor shaft that I made. And I made another motor shaft for this one. Needs to be made a little better, but in the future I'm taking all these motor shafts off and doing something different. That's why I have this set up like this. But I'm not going to give all the information just yet until I actually have some success in it. Then I'll tell you what I did and how I did it. So anyway, this video is to show you that I got it finally mounted good. There's nothing that's gonna move, and I adjusted where the motor sits at so I could get the most torque, the most free running and fast spinning at low voltage. And I have this blue wire right here. This comes from the back of this generator head. So this blue wire, I just have it stuck in the center of the crack of this wood right here, just to keep it low. And you can see it comes from the top right there out the back of that generator motor. See, right there. Just so you guys don't think I'm making this up. Anyway, I got that coming out there. And I have it coming straight into this lead, these two leads that connect straight to my voltage meter. And it's set at AC voltage because you're definitely going to have it set at AC. I just wanted to show you that this is just connected to that. Right there. I'm using my video camera. I got tired of trying to record stuff with my phone. It's fine. Anyway, as you can see, I have that set up right there. And I'm going to hook up and show you what the voltage is. I got this other voltage meter right here. See, I got it set up perfectly because you can see I got it to lean up against both of my 2x4s that are connected to the generator stuff. So you guys can see all this. Right now I'm going to, those are the leads coming out of my motor controller right there. Goes straight from, I know this is a lot of wiring and it's looking kind of crazy, but I'm going to just show you right here. You see those blue wires coming out, go straight into the back of the motor controller to give the motor controller power. This is set at 22 to 27 volts, give or take. And then out of the back of the motor controller, I have this wire lead coming out. So basically, input and then the output to the motor is right here, and I have that clamped on with some clamp leads that I made myself that go straight into the back of my motor right here. Anyway, I'm going to put in line so you can see what voltage I'm using on that little motor that is spinning this generator. This one's more sufficient because it's using less power. That's what I like about it the most. Like I said, I like my bigger motor, but it uses more power to operate, which I'm trying not to do. But I'm gonna set it up in the future so it won't do that, basically. Anyway, I'm gonna set this down real quick and go ahead and hook these up real fast for you. Sorry about this. I was trying to get everything set up before I started this video. I apologize. Okay, there goes one. And then 2. Gotta set it to DC. Okay. Alright. Now, I have that in line, as you can see. It's the back of that motor, so you know exactly what volts I'm using. And this is set on DC, so it lets you know what volts I'm using in the motor. And this is the output AC from the generator. Anyway, I'm going to turn it on and show you that I do get power. And it works great. As you can see, I'm only using 3 volts, and it's so high off the charts that I have to bring it to 200. Right now, I'm at 79, and only 3 volts electricity is running at 79, 78 of AC voltage. Now I bring it up. Almost 5 volts of electricity, I get 120, 130 volts around there of AC. And that's not as far as I can bring it up either. That was almost halfway on my voltage my motor controller. But that's not. This isn't a video of just my setup. What I'm going to do is show you guys something that kind of shocked me a little bit. I mean, granted, it is voltage that I'm messing with, but I went to Radio Shack today and bought me, there you go, I bought 2 of them. This is a transformer from Radio Shack. They're rated at 120 volts, and it's basically 25 volts at 2 amps. It's like 12 and 12, 12.6, 12.6 volts on the side or whatever. This one for some reason is actually messed up, and I think it's because it was open and somebody messed with it. I was thinking about returning it, but I may open it up and rewind it myself using copper magnet coil, magnet wire. I'm sorry. And this is just another one I bought. This is rated for 12 volts. But I bought, like I said, I bought 2 of these, and here's the other one right over here. I'm going to show you the voltage coming out of this thing. It's amazing. Like, I thought I was saving power before, but this thing right here is doing a really, really, really good job. Sorry, I'm trying to get a better picture for you guys. I'm just having a little trouble getting around in my room real quick. Anyway, I'm gonna hook this up right here, this transformer, and then I'll show you exactly what it can do. So I'm gonna set the camera down just real quick again. I have to set the camera down because I wanted to show you the voltage coming out of it already, like I wanted to show you guys the voltage that I was getting just with 3 to 6 volts of electricity. I was already almost house current. So what I'm going to do is have these leads right here. I don't know if you can see them. Yeah, these leads that come out of the generator are going to go into the back of my transformer. So I just need one of these wire leads. As you can see, they're the yellow ones. It comes with 2 yellow ones and a black. All I need is 1 yellow one, so I'm just gonna hook this positive lead right here to one of those yellows right here, and then my negative lead will go over to that black common ground, the black wire lead right there. Okay, so that has that power coming out into it now. So it's gonna basically, from the generator head, it's going into this transformer, and then out comes voltage. So I'm gonna set this down and hook up some more wire leads so you can see the voltage. I'm gonna connect this red one that I have here for my positive on my voltage meter, so you can see the difference. connected. And now I'm going to get this yellow one right here. Connect that to, the only reason I'm showing you my connections and all that is because I don't want you guys thinking that I'm making this up. I'm not a faker. I'm not gonna lie to you about this. I want help is what this is one of the reasons why I'm doing this. I don't want you guys to think I'm lying and making this stuff up, because I'm doing research every day and night, checking, watching YouTube videos, researching, looking at wiring diagrams, all kind of stuff. And I want people's feedback, I want their information, because I'm trying to help all of us kind of get closer to having free power. And it's something very complicated to do, but I've seen a lot of videos that have done it, and I believe that they have done it. It's just a complicated thing, and I'm not going to get into all the reasons why nobody's really been doing it, because I don't want to get in any kind of trouble. But like I said, the reason why I'm showing you these leads is because I don't want you guys to think I'm lying. I want you guys to go ahead and do stuff like this, that when you research this and be like, oh, he's a lie. I don't want you guys wasting your money on stuff, because I'm funding myself. This is a lot. This is expensive stuff here. This setup right here probably be around, I want to say $200 to $300 so far, with voltage meters, DC motors, generators. I just spent $30 at Radio Shack today just on some transformers. So this stuff can get expensive, and like I said, I'm funding myself, so I really wouldn't want somebody buying the same stuff I'm buying and wasting all that money if it didn't work, because I would feel pretty upset if I was trying to copy up somebody else's and replicate it and it didn't work and I spent all my money on it. So I don't want you guys to, I don't want to feel like that, and I don't want you guys to feel like that. Anyway, I got my connections hooked up. I got the generator's wire going into here, and then out of the transformer goes into my voltage meter. Now I'm gonna go ahead and start this up again, and I'm gonna show you guys the voltage I get now. And remember, it was producing around 120 to 130 from basically like 4, 5, 6 volts tops. But check this out. Less than 3 volts in, already at 122, 123. 3 volts will get you house power. That's what I'm trying to say. The coil windings in here that come through the transformer is a step-up transformer, I guess. See, I bought this for a step down, but it's actually a step up. And I don't know why that is, but it's just doing that. Because I wanted this to go from 120 down to 125 or whatever. So maybe I got it wired up wrong, I don't know, but I do like this. Like I said, it's house power right now, and it's only running at less than 3 volts of electricity. I mean, that's like 2 AA batteries. Now I could bring it up, and it brings up the voltage. Let's just go ahead and bring it up to like 6 volts. See, it's off the charts now. I gotta set it back some again. Down just so I could talk to you guys, because it's pretty loud. But like I said, look, less than 3 volts, like 2.5 at 100, almost 100 volts of AC current. Now, you may not believe it. I mean, you can see it, but you don't believe it because I don't have a load on it, and I get that. So what I'm going to go ahead and do for you is I'm going to have to take off because I don't have a whole lot of wire leads and stuff. So I'm gonna take off from the voltage meter here, and I'm gonna connect this LED floodlight, lamp light or whatever, floodlight, whatever you want to call it. As you can see, no gimmicks. The floodlight is connected to this little light holder, which has 2 wires coming out the back right into here, and the wiring is coming right through. Let's get out of it. Comes right through, and I have them sitting right behind here. So I'm just going to take these out. See? And I'm going to go ahead and hook that up into my transformer. So just give me 1 second so I could just do that. I'm going to try to angle the camera so where you guys can see it. I'm just going to take this off. Let's see, that was my positive, so I'm going to go ahead and hook the positive up from the light over to positive on this wire right here. It's hard to do because the wire is trying to get away from me. Alright, hold on. Shoot. Alright, got the wire in. And now I'm going to get my negative. Unhook my cable. Now you see a load. It put a little strain on my motor, but it's still running at like 2 volts. It put a strain on the motor, I'll give it that. But you see it's flickering, but once I bring it up a little bit, now look at that. Using 2.5 volts, and I got a LED floodlight shining really bright. Sorry about the lighting. I mean, I know it's like direct light into there, and it's pretty bright. But I just wanted to show you that it is working, and I can bring it up too, so it could even get brighter. See how bright that is? And it's only at like 4 volts almost. Now I don't know the amp draw, and I know everybody would want to know, so I'm gonna have to figure out the amp draw for it, but I'll put that in the description of how much amps is actually going into that motor and all that. But I just wanted to show you that the LED floodlight actually does work, and I was running at a very low rate, very low voltage from basically if I hooked up a battery. And granted, I do have a power supply hooked up into this, but 3 volts, I mean, you could get that out of a battery. I mean, I don't know about the amp draw. I'm pretty sure the more amps it pulls, the quicker the battery will die. But I really don't think they're using that much amps inside of there. And I'm going to keep doing some testing and let you guys know what I come up with. And this will actually work with this motor too. Even though this motor doesn't spin very fast and produce a whole lot, this light will still come on. It's rated at... the highest I got out of this was 40, I think, 40 volts of AC current because of the RPM speed of the motor. It's too low for it to bring it up any higher than that because it's not using the rated voltage or whatever. It needs more volts in it to bring it up more. But what I'm trying to say is, with that being like 40 is what I could get it up to, I got it into the transformer, and the transformer gave it like 90 or so, or 96 I think, and brought that light on too. Now yes, I understand it's just a floodlight LED or whatever, but I can change this out. I mean, I do have some other LED lights here, like this one. I like these. They're pretty good, but my favorite is that one over there. That one's just one of those little candlelight ones. But it's a LED, and if you were wondering why this light is on and what it's going into, this is that super jewel ringer that I made a video for a while back, and I just had this set up so it could save power while I use like a light or whatever. And plus, it's like I have like a dimmer switch type in here, so I could adjust the voltage coming in and out of it. And basically, it's right now it's sitting at 8 volts from this power supply too, because I have these two leads go into that jewel ringer circuit. But what I'm trying to say is the transformer gives enough power to turn on this LED floodlight at a bright rating, only using very low voltage. Now the amp draw is something I have to mess with and figure it out, but for the most part I do have it set up, and when I do figure out the amp draw and all that, I'll let you guys know about that. But the good thing about it is I've been working with these relay oscillators, basically the MOTEPS charging circuit. And I bought another relay. I got 2 already wound up. I got a third one that I want to do. They're I'll show you, 275001 from Radio Shack. All you gotta do is pop that cover off, solder a wire to the inside of the open circuit, the normally closed circuit, or I think that's what it's called, I forget. All I know is you solder a wire to a piece of metal in there that kind of looks like brass or gold. You have to make sure you scrape that gold off real good to get to the silver part of it, because you want a good connection. And then out comes the diode. You connect this prong right here to that wire that you soldered with the diode and the neon bulb to it. See right there, I got this neon bulb going into it. And then this part right here goes into the positive of your charging circuit that you're trying to charge up. And then the positive from your battery is this wire connection right here. And the negative comes from the bottom one right here. So if you could see it, basically positive right here, negative is the blue, and then positive will be the right side and the wire you soldered and a wire from the neon bulb, all connected to one solder joint that goes into a diode. And the diode is the 1N4007, I think. Yeah, you could probably even see the 7 if I get close enough. Hold on. Yeah, you see that 7? So just to make sure you know, and it's outward, you can see the tab coming out. I really like my camera, it works great. But basically I made 2 of these, so I put them both together because I figured, you know, double the power spikes the better, or whatever charging. So I put both of these together, connect both of them pretty much up to each other. See, the same wiring gets connected to the same wiring. I just tied it all together. As you can see right there, I have both the diodes, this one right here and that other one right over there. See, you see the 7 on there? Right there. 2 of the 7s put together on that wire clip. It goes down into that green, goes into that red clip that goes into, I have a capacitor here. It's a 16 volt at 12,000 unifarads. I mean 120,000 unifarads. And it works great. Like, this is my fastest charging one, I guess, because I did battery, but it seemed like it was taking the battery forever to charge. Like, I mean, it could stay running forever and the voltage doesn't really go down in the battery that you're using to charge. It just takes a very long time. But the capacitor charged within a few minutes. But my regular batteries, or my battery capacitor thing that I have made, it was charging kind of slow. But what I'm trying to say is, this right here is only a 12 volt battery, but it charged this 16 volt capacitor up to 16 volts. And I got this light switch on it. I know I got a lot of crazy like wiring hanging off of each other. I know it's messy, but I wasn't really trying to do a video, but I'm just trying to explain what I'm trying to get at here is this. If I could get this circuit to charge up like how I seen a few of these videos where they have it oscillate and charge the same battery that it's using, and it won't go anywhere while it's using a load, like the little LED lights that I've seen on some videos. If I could get it to do that, I'll be able to have this run my generator motor, spin my motor, because I mean the LED light that they were using used like 12 volts basically, because it was in line with this. If I have this plugged up to my motor controller and have it charging itself and while it's oscillating, this battery will never die. Oh, the battery that you're using should never actually die while it's still charging and using a load while it's, so the load that I'll be using is going to be in my motor. The motor controller will spin the motor at that low voltage. I mean, I was using what, 3 volts of electricity. So if I use 3 volts of electricity off of this 12 volt motor, 12 volt battery that's charging itself and staying at capped off at its rated voltage, that's free power. Because this battery or whatever battery you're using should never die, because it's constantly being charged while it's using a load, and the load is the motor, or my motor controller to the motor, and then that spins my generator, which produces enough light to have my floodlight and our regular lights added to it. Granted, like I said, I gotta do the amp draw and see what the amps are looking like, or if I can even get the amps to come down some. But what I'm trying to say is, by adding a load, I should be able to hook this up, and basically if I could hook this up to my motor controller, which will spin that generator, I'll have basically free power. And if that doesn't work, I have another idea for this setup. See, what's good about my setup right here, both these motors, it gives me the ability to do more. I have like 3 or 4 different ideas just for this setup, and that's what I like about it. It's so easy to configure. I just have to run a lot of tests, and I still got a few more parts I have to get, like a different transformer. I have some other ones that I was looking online that I'm thinking about getting. And not just that, but the some magnets and some, basically I want some N52 magnets, and it's not gonna be for the motors, for something else I'm not gonna get into right now. But I hope you guys liked the video. If you have any comments or something you need to add to it, let me know anything. If you know anything about that circuit that can charge itself using the load, like if you have any idea of how he was getting that done. I mean, I know I've seen that basically I'm gonna need a transformer for that too, and I've seen some people make one, and I have capacitors right here. I have plenty of these capacitors. They're ones in my capacitor battery. Matter of fact, my capacitor battery is right over here. I'm gonna show you what it looks like. It was on my other videos. One of the lights, some of the lights are out because they burnt out, but some of the lights aren't. So this is my capacitor battery. I call it capacitor battery, I guess. I don't know. I have this little switch on here that lets you know the voltage in it. And basically, this is a balance circuit from. This is a balance circuit, so you can see how the voltage in every capacitor, and these are the capacitors I'm using. I still have plenty of these, so I will use them for my basically the oscillating circuit for this. So I'll just solder a bunch of these together to make the voltage that I need, like 16 volts or whatever, just like this capacitor battery is. And it's rated at 350 farads at 2.7 volts DC. Like I said, I have plenty of these. I have enough probably to make about 2 of these again. But what I'm trying to say is, if you guys can help me figure out how to get this circuit to charge itself and have that whole oscillating thing going while it's using a load, like a little LED light, then that will help me finish this project over here, so I can see if that works good for this. Now if it doesn't, then I can move on from this and try my other idea. But I'm not gonna just jump from idea to idea to idea and not ever figure out which one actually works or not. So I just want to stick on one thing. So that's why I went ahead and bought another relay, so that way I can make another one of these oscillating circuits, because triple the power. I just want to get up to 3 since I have another neon bulb, so that I could just use that neon bulb and have 3 of these, so it kind of works out. But the voltage spike does work, and if you guys have any questions, comments, like I said, this system does work. Obviously you've seen that light come on, and I've actually tested this system with a house fan. I just plugged the fan up right to the back of that generator, my little generator right there, the white one, and I actually had it running the fan, so it does work. I didn't plug any TVs or anything like that into it, just because the frequency is so high and I don't want to burn any of my stuff out. But I would love to figure out how to bring down frequency like that too. I've been trying to look up like anything, but I haven't really seen nothing yet. But I'll keep doing research on that too. But if anybody got any questions, comments, whatever, just please, I will definitely read all that you guys have to say. Even if it's negative, which I'm pretty sure I'll get a bunch of negative stuff, like, oh, you got wires everywhere, you had your camera moving around too much, you talk too much, it's whatever. I'm just trying to help you guys to help myself as well to get us free power. So if you think I'm babbling too much, I'm sorry. I'm just trying to explain what I'm thinking, and if I'm thinking wrong, I want you guys to call me on it and let me know why that isn't gonna work, because I don't want to spend my money on stuff that may not work for me. So help me so I can help you guys. Thank you, and goodbye.